This is Griffiths Electrodynamics, problem 1.23 in the 4th edition, dubbed only for masochists. Now, I'm no masochist, but I do like math a lot. So, we'll meet halfway and I'll only do the first half of this problem, which is going to be proving product rule number 2. Perhaps I'll do product rule number 6. Product rule number 2 in this edition of the book refers to this specifically. Grad times A dot B is equal to B. Sorry, my bad. Messed that up. Times A dot B equals A cross grad cross B plus B cross grad cross A plus A dot grad times B plus B dot grad times A. Okay, so this is the whole thing. Now, one thing that you might assume by this, and you know, it says this is for masochists, so there's a temptation to try to make it a lot easier than it seems. Now, I will show you what happens when you think you can do this. Now, when I initially saw the problem, was like, okay, so what if I just use the back cab rule on this? So this is going to be equal to, via back cab, so it's going to be grad times, if you aren't aware, the back cab rule, let me write this out quickly. Back cab is the idea of A cross B cross C equals B times A dot C minus C times, can't write, A dot B. And you'll see this is BAC, CAB. This is a sort of, so the mnemonic is back cab. So using that idea, we're going to have back, so it's going to be BAC. So that's going to be grad times A times B, A dot B. And then cab would be B times, cab would be A dot grad. All right, and then if you notice, we'll just do the same thing for B cross grad cross A. We'll just get back cab again, so it's going to be grad B dot A minus cab, so it's going to be A times B dot grad. And what you might notice is that in the original equation, this part here corresponds to this part here, right? As you can see, never mind, sorry. That was the wrong one. It corresponds to this part, right? So you have A dot grad times B, and you have A dot grad times B here. And same thing with this. This seems to correspond to this. However, and you might say, well, those just cancel out, and we're just left with the left side of the equation. So we've got this and this. The only issue is this is summing to actually being equal to 2 grad times B dot A. So what we're essentially saying is the gradient times the dot product. And remember, these are, what's the word? Is it commutative? I think it's commutative. I can't remember right now. Dot product's commutative. So we're saying that, in fact, this left side of the equation is equal to 2 times itself. What's going on here? Now, what we did here was improper use of vector calculus identities. Unfortunately, this rule, this back cab rule, does not hold for our case here with the A cross grad cross B. And the reason why is because it's a gradient. Gradient multiplication, the gradient is not a simple vector, it is an operator, and thus we cannot treat it like a normal vector. We cannot treat it like a normal vector, we cannot treat it like a normal matrix. It's not going to work out. So unfortunately, this very simple seeming solution to the problem actually ends up with an extra solution, and it just shows that this is not a valid method of solving. So, unfortunately, we're going to have to go about this the long way. All right. How do we do this? So, first of all, what I want you to notice is, and there is actually the previous problem in Griffiths E&M shows has you do this, but I'll just show you here. If you want to prove this on your own time, you can. But what we're going to get, and we're going to just do this in the x direction because it makes this the easiest. So we have a dot grad times b. This is going to be equal to, and it's a fairly simple proof, this is going to be equal to, ax times the partial bx here, this. Okay, and I messed the parentheses up, but whatever, I don't ever. And it would be like this, and if we did the full vector, this would be this times x hat, and then every single component is actually equivalent within this thing. It's just going to, we would have the three. However, because every single component will have the equivalent thing, we're only going to be solving this for the x component, and that will prove the whole thing for the entire thing. So this here is what this is equivalent to. These two are equivalent. I guess the equal sign should have made that clear. The next thing that we're going to have to do is we're going to have to do the cross products, the triple products, correctly this time. A cross grad cross b in the x direction, and you would get the exact same result with a few letters switched around, but the logic works out for the y and z direction. So we're just going to be worrying about this. What does this end up working out to be? Well, if we think about the 3x3 matrix, and you can write it out if you want, but I'm not going to because I don't have quite enough room on this little iPad screen that I'm writing on. This is going to be equal to, remember, this will actually be equal to AY times grad cross B minus AZ times grad, oh, wait, sorry, this is in the z direction, of course, just to be clear. Grad cross b in the y direction. And then this will, of course, then be equal to ay times del by, del x minus del bx del y. And I'm reading off from notes here because I didn't want to do this calculation. Minus az times del bz del x minus del bx del x. Okay, and I say del even though this partial sign here is not actually a del. I just say del. Del is actually this operator, the grad operator, but I just say del because it's close to a d, but it isn't a d. So this is what we get for A cross grad cross B, and you will get the exact same idea for B cross grad cross A in the x direction using the same logic. We're going to find out that this is equal to by times this, blah, 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 minus bz times del az del z minus del ax del x. Okay, so this is what we're going to have to work out. And if you really want to, you can work this out on your own. That would be part of solving the problem. However, I will leave that to you, I guess, so that you can't just follow along. You will have to work this out on your own. And now, what we have is we have all of the components. I will, I suppose, put in the fact that this here is equivalent, and then this is all in the x direction, by the way. I should make clear again that this is all just in the x direction, and you can apply the logic again in the y direction, but it works out for the x, so it will work out for everything else. Okay. And this is equal to, what is this equal to? This, and this should be very straightforward. It's literally just the exact same logic with different letters, and I'll write it down here, I guess. BZ, del AZ. Oh, wait, I guess that should not be, there shouldn't be an A there. There we go. Okay. Why did I write this here? I'm not sure what I was doing there. I guess it doesn't matter. Okay, so we basically have the whole thing here. The only thing that we need to work out now is the left side of the equation, which, as you may or may not remember, considering it was a while ago, was equal to this. So we'll work this out, and of course we're just going to work it out in the x direction. All right? Almost there. It is, geez, it's 1 a.m. in the morning, so I'm sorry if this video sucks, but it's my first one, so we're with this whiteboard app, so I figured I might as well get it out anyways. So this, as we're going to find out on my notes on this is going to, of course, as we know, we should note A dot B is equal to, and it doesn't matter because it's a dot product, so it's just AX BX plus AY BY plus AZ VZ, right? Okay. So now that since we know that already, it's AX BX AY BY AZ BZ, we know that each component will be exactly the same because that's all it is, and the grad is not going to change anything. So we actually know that this is going to be the product, but we need to use the product rule because what we're doing is we're taking the partials with respect to x of all of them. So in the x direction, at least, this will be equal to ax times partial of bx with respect to x plus bx partial of ax with respect to x plus ay partial by with respect to y plus, I guess we'll just do it down here, by partial ay y. Oh, I'm bad. My bad. This is, sorry, give me a second. I messed this up. This is, you can really tell it's super early in the morning for me. I guess late at night. This is, I'm dumb. This is the partial of by with respect to x plus because of course this is a gradient, so we're only taking the x component of it, right? And then what we want is this here, and then of course we would just replace the del x on the bottom, the partial x on the bottom with respect to y and respect to z as we get there. Yeah, this is what, oh my gosh, I cannot, I probably shouldn't do this video, but I'm just going to release it anyways. I'm making so many mistakes. There we go. Okay, so this is what the left side, let me just circle it because I can barely read my own handwriting on this thing. This is what the left side of the equation has come to. Now, if we combine all of everything from this, and this, what do we notice? All right. We are almost there, I promise you. We notice, first of all, very clearly, that, I forgot. We have to work these out, which is very annoying. I do not want to work this out. Oh, wait, no, we don't. I'm dumb. We don't need to work this out. Okay. So, first of all, we have this negative. We have a few negatives here, so what we need is for this stuff to cancel out, basically. All right, so we have negatives here, here, and here, here. So we're going to have a negative here. We're going to have a negative here. We're going to have a negative here and a negative here. Everything else will be positive because, of course, the negatives cancel out. So ay times negative, so negative ay times derivative of bx with respect to y. Where do we have that? Derivative of bx with respect, oh, that's not important. Ay times the partial of bx with respect to y. Where is it? I can't find it right now. Partial of bx. I can't think. Isn't there a partial b? Where's the partial bx with respect to y? Oh my gosh, I can't think right now. Okay. Why do we have our partial bx with respect to y? I can't think, man. Oh my goodness. Okay. Where are we? Where are we? A dot grad times b. Oh, I'm a fucking idiot. Okay, these are all x's. These should be x's. That's why I'm confused. It's in my notes too. Okay, those are x's. This is an x. And this is an x. Okay? I don't care what anyone says. Those are actually supposed to be x's. Oh my goodness. Okay. So, we almost have this now. I just want to die, dude. Why am I doing math at 1:30 in the morning? Whatever. Okay, so here we are. Partial with x. Partial bx with respect to y times ay. This is going to cancel out with this. So this goes to 0. Right, so these two go to 0. This here, partial bz with respect to x times az. We have, where's our az? This here. That dies. And, oh, I guess it's just this part that dies. I'll erase part of that. All right. Next. Next. Almost there. We have these. this negative by times the partial of ax with respect to y. This here does. And finally, this partial of az with, I don't know. I can't think, dude. I can't think. This is supposed to be an x, that's supposed to be a z. Okay. I can't, oh my goodness. I can't do my math, dude. Oh, I'm gonna die. I don't know why I keep saying I'm gonna die. I just feel like I want to die. Anyways, partial with ax with respect to z. That's here. That's here. So we got a little decoy there. So that does. And, oh, I just realized I could have paused while I was thinking. Probably should have done that, but whatever. So that does, and then this also does, meaning that we are left with by times partial of ay with respect to x. So we're going to be left with a few things. By times partial of ay with respect to x, that's here. We have that, this portion here. Next, we have bz times bz daz dx, or partial of az with respect to x. So that's this here. And we'll find that here. Then we have our component here, ay times partial of by with respect to x. That's here. Az partial of bx with respect to, wait, no, sorry, this is supposed to be dear God, did I mess this up again? What the fuck is wrong with me, dude? This is an x, and that's a z. That's a z. Okay, there we go. I can't, dude, I can barely freaking think. I probably messed this shit up. I don't care. I don't care. Oh gosh, yeah, this is getting uploaded to YouTube. This is getting uploaded to YouTube, man. I don't know what to tell you. Alright, this part here, az dbz dx, did I already circle it? Yeah, that's there. And then we just have a few things left to do. We have this part, bx dax dx. There we are. And finally, the last part, which is right here, ax dbx dx, and there it is. So as you can see, that was the most flawless, error-free proof of all time. Thank you for watching me slowly mentally disintegrate at 1 a.m. because of Griffiths E&M. I've read through this entire book at this point, and this problem destroyed me. And it's freaking basic vector calculus. I am no masochist, but I put myself through hell for this, so I hope you're happy. Thanks for watching.